A very good morning and a warm welcome to session 9 of Professional Development Program organized by BMS School of Architecture and Indian Institute of Architects, Karnataka Chapter. Today's session is titled Building Information Modeling, that is BIM, presented by architect Shrinath Tandur. Architect Shrinath Tandur holds a BArch degree from Bangalore University and an MPhil in Architecture Studies from Chinese University of Hong Kong. He is a fellow of the Indian Institute of Architects and currently serves as a chapter honorary secretary, joint honorary secretary 2021-2022. He began his first foray into BIM with early versions of ArchiCAD and photometry simulation with Lightscape, now a part of Autodesk. As a quality manager and auditor, he carried his firm to an ISO 9001 certification. And while in Chicago, he worked with FMCAD integration, which was then a relatively new subject. Over the course of his career, he has interlaced professional practice with academic research, and he has published and presented papers at conferences such as ANZA SEA in Hong Kong, WSF Mumbai, and ISARC in Oulu, Finland. He was a speaker on BIM implementation strategies at Autodesk University, Mumbai and Chennai. He is a visiting faculty member at Bangalore University, teaching climatology and passive design while discussing the latest trends in building-related technologies with his students. His combined experience at various firms over the last 3 decades and collaboration with various domain experts has resulted in a rich variety of architectural work in multiple countries on commercial, institutional, industries, and defense-related buildings, as well as group housings and exclusive residences. His firm administers projects including the use of BIM-based delivery mechanisms, employs designers and visualization artists, works with select group of consultants and utilizes the latest in design virtualization software to achieve its objectives. Thank you, sir, for accepting our request to be a part of this program. The platform is all yours.
Thanks, Ranjan. Thanks for that introduction. Thank you, Dr. Shaila, and thank you to the Indian Institute of Architects, Mohan especially, leading this team very, very competently. And I would like to start by saying that this subject, of all the other subjects in this webinar series, I think this is the one that architects are probably more familiar hands-on than the others. The others are all pretty technical, such as the use of robots in construction or artificial intelligence. Those are on the fringes. They have not yet made their way into practice, architectural practice. Very few architects probably use those techniques. So I will launch my presentation. Can I share my presentation now? Yeah, so I'm going to move to building information modeling. And while it says emerging technologies, we should realize that it has been around for over 30 years in some form or the other. But in many cases, it has been in the field of advanced engineering, advanced institutions. So architects have adopted BIM into their practice, but still there is a hesitancy, and still we see a lot of architects who ask questions like, what is this BIM? I already have CAD, why do I need BIM? And if they are convinced that they should go for it, then they say, how do I integrate it into my practice? Have other architects successfully implemented? BIM's implementation seems to be expensive. Can I recoup my investment? Or probably the most important question is, can I get my clients to pay for it? Now, these are the questions that we will try and look at in the next few minutes. There are many aspects to BIM. It's now a vast subject. Building information modeling started off very basic, and now it's gained a lot of traction. And in the time allotted today, what we can do is not really a deep dive, but we will look at an aerial view of aerial view of the whole thing, and we'll look at the challenges of BIM in architectural practice. Before I get into BIM, I want everybody, especially the younger architects, to take a good look at this building. This is probably one of the last of the skyscrapers that were entirely designed by hand. This is the John Hancock building in Chicago. It's 100 stories tall. It's got a very unique structure in that it's a tapering structure, which means that every floor is different. There are no typical floors in this building. It was designed by a Bangladeshi structural engineer, Fazlur Khan. I think many of you heard of his name, and he's very famous in the field of skyscraper design. And he came up with this. He reinvented the tubular steel structure in the bracings that you see. He also designed the Sears Tower in Chicago. He worked very closely with Skidmore, Owing, SOM in those days. And his ideas were today across the world, many skyscrapers are built with this kind of technology. But the reason I am showing this particular slide is because everything was done by hand. So every plan was drawn by hand, every floor plan. And what the uniqueness about this is, a floor plan and its reflected ceiling plan themselves have a variation because of the tapering structure. So it's a very, very difficult building to draw and implement. And they did all of this by hand. So before anyone becomes enamored with BIM, I'd still like you all to look at this and digest the fact that an architect's mind still is much more important than any tool that we use. Of course, the computers today help us free us from doing certain repetitive tasks, but still the thinking should be yours. So we look at a brief history of BIM. We look at how do you define BIM and differentiating between 3D CAD and BIM, because there's a lot of confusion there. And again, in the audience, I don't know how many people are expert at this and how many people are in the process of implementing and how many of you are new to this. So I'll have to balance the talk without getting too deep in it. And we'll look at things like BIM dimensions and the granularity of BIM. And one important thing that I will touch upon is the interoperability between architects and their consultants. See, that the client normally looks at the architect. They don't see what's happening behind the scenes. We have an array of consultants, and sometimes it's very specialized, and not all of them are on BIM. So how do you work it out? So implementing BIM in an architectural practice and setting up a computing environment, very, very important, because you are now handing off your thinking. After you've done your basic thinking, you're now handing it off to a production environment where your computing environment has to be really solid. So the impetus to design, when I use the word design, I'm using it with quotes, because people confuse drafting with design. Earlier, you used to have the acronym CAD with the CADD, computer aided design and drafting. Most of the time, it used to be drafting a model, whereas virtual buildings today have their roots in manufacturing. And here is an astounding example that happened in the early 90s for the first time. And before this, other military aircraft had been designed on some form of CAD. CATIA was used from Dassault Systems on IBM hardware this was by Boeing, and they designed a jetliner, commercial jetliner, a full body, a wide body jetliner, completely designed without making a physical model. They did make a nose section and compared it and found that their CAD model was so accurate that they need not build the entire plane first before fabricating its parts. Within 2 years, they finished the whole thing and actually took to the skies in 1994 for testing and commissioned it for airlines to pick up from 1995 onwards. So this was one of the first examples of a complete computer model that went into production. So we are beginning to see that happen in the building industry. So we can say, if mechanical engineers could do such complicated design work wholly on the computer and resulting in a 300-ton aircraft capable of carrying 300 passengers, I'm rounding off these numbers, but the ability to climb beyond 30,000 feet and safely complete at least a 3,000-mile journey, surely the construction industry could not be far behind, right? Actually, even though this happened in 91, 92, 93, BIM has been around since the 70s and 80s in some form or the other. And like I mentioned in the beginning, much of this remained within the halls of academia and government-funded research labs. I know some of this because I myself did some research during my master's program, and we actually built models using Cartesian coordinates instead of actually drafting them. So we understand simulation from first principles. And a few years later, Graphisoft was one of the first companies that released a CAD, a building information model, a building software aimed at architects that could be run on a personal computer. That's the key difference, because personal computers were still, as compared to today, were still quite slow and very limited in their memory. Those of you who worked with early versions of Windows or even before that on DOS know what I'm talking about. And despite the economy of the computer, the programmers managed to fit in a complete building design software. And ArchiCAD was really an eye-opener for all of us. I started working with ArchiCAD in the 90s and realized what I had been missing, because by then we were already pretty good with AutoCAD. We were pretty good in making 3D models in AutoCAD, but this suddenly changed the game. Then many years later, Autodesk purchased Revit. Revit also has its background in manufacturing. The people who started Revit did come from the manufacturing field. And then Autodesk started releasing a commercial version. And we were on board with Autodesk right from the very first iteration in India. I think in 2005 or 2006, we started playing around with Revit. We were exploring many options, and I think Revit stood out because of its capability to work and produce AutoCAD drawings, which was very important for us. And it became a major competitor in the field, along with Bentley Systems, Dassault, and ArchiCAD, among others, who were all already there in this field. Now, we deal in BIM with a virtual three-dimensional space, okay, within which we create virtual three-dimensional objects which have parametric properties. I'll get to that a little bit. So, which closely simulate the real-world counterparts, which is very different from just building a 3D CAD model, because the properties of the objects that you create, which are inbuilt into the BIM toolkit or BIM library, or you create your own objects within this virtual environment. And eventually you come up, I think yesterday or day before, one of the speakers used the term digital twin, right? So that means you have a building that is as closely modeled on reality and its behavior, whether it be with relation to daylighting, whether it be with relation to its thermal property, all of them simulate or mimic your what's in the real world, or what's going to happen in the real world. So it gives us a lot of predictive capability. So what are these properties that we are talking about? It includes material makeup. Now, in a CAD model, you could have a vector-based outline, and then you can sweep it along some curve and then make yourself a surface. But it's not really a digital twin of what could be built. So the material makeup, which includes properties such as density or thermal conductivity, or whether the object is opaque or transparent, and even the surface characteristics, how rough is it, its texture, its smoothness, its color, its reflectivity, does it have elastic properties? Like if it's made of, in automobile industry, they are very interested in the performance of a tire, for example, for their vehicles. So you need to know how these materials behave. And then you also have dimensional constraints beyond which a particular object may not perform to its design, to what it was designed for. So these dimensional constraints are another example of parametric properties. One simple example of a parametric property is you may have a column that goes from say the ground floor or to the first floor, and then it's a street side building, and so the owner says, I would like to have shopping oriented ground floor, and I need a higher floor. So when you lift up the first floor or the immediate floor above, the column should automatically connect the two. So one of the properties of that column will be that it fuses itself to the lower floor and to the upper floor, so that you don't tell the column what its height is. You just play around with the levels, and then the column takes one column or 100 columns all take the same parameter to decide how tall they are. So among others, other properties such as fluid dynamics, if you're doing airflow modeling, or you're doing something to do with gravity effects, or you're trying to calculate lighting in different atmospheric effects, depending on how cloudy it is, or what kind of a fog is there. Material handling, this is something very important for contractors, because when they plan their construction activity, a material handling is how can a crane come in and go, how can material be stacked, how can material move around on a site, especially with congested sites. All these can be modeled, and once you model all of this, the parameters that you assign to them will affect your design. It tells you whether something is possible or not. So then one of the important things when you talk about defining BIM, if BIM is a three-dimensional space, what is all this talk about 4D, 5D? I hear all this all the time. And so one thing to note is that in constructions, and nothing is instantaneous, and building construction is an expensive process. You look at contractors, especially the bigger projects, where the construction timelines are very, very important. Phasing, sometimes the projects are in multiple phases. Sometimes their activities are dependent on each other. And therefore, just like in physics, you have time assigned as a fourth dimension. Somebody tagged BIM 4D for project timelines. And then there's the issue of the other elephant in the room, the big elephant in the room, which is cost. And therefore, you need to quantify everything. You need to know every single part. You need to know which comes first. You need to know the cost of putting something in place, not just the raw material, not just the transportation, not just the labor. You add them all up. And then this is what contractors are very, very interested in. And most of the time, this BIM 4D and 5D that we talk about, which is the fifth dimension is cost, is something that larger contracting firms are very, very invested in. Architects, not so much yet. Most of the architects are still building models rather than worrying about timeline of the project construction, unless a contractor asks for it. Developers do that, and costing is something that we try to quantify and assign a cost. But still, this is something more of a contractor or builder's role. And while the cost is not a dimension, remember it's an information field. So the word dimension is used to represent any information field you wish to tack on. And each of those information fields have their own parameters. And so you have this 4D and 5D mentioned quite heavily nowadays. And then there is maintenance over the life of the building. And that's another information field, and you can call it 6D, which is typically the facilities management component. Then you have energy performance forecasting, and somebody has tagged it as 7D, or the seventh dimension. And there are many people who call this 6D and 7D in the order I'm saying it. And there are some who flip this around and say 6D is for sustainable architecture and 7D is for facilities management or the life cycle of a building. It's okay. I mean, it's what you define and follow. That's perfectly fine if they are interchanged. And so in any BIM environment, you automatically start with your 3D by default. You have 3D, and then you incorporate any of the other Ds independently. You can, for example, do your energy studies and not worry about costing. You can or timeline of construction. You can assume that after you modeled it, the building has been constructed, and therefore, how will it perform when it's been constructed? You can completely skip the 4D and 5D process if that's what you're interested in. In fact, early studies of buildings typically skip the timeline and costing part. You build your 3D model and then you do your energy studies on it, which actually affect your design. And then you can go back and revise your design to suit the results that you obtain. So here's a diagrammatic representation. You have here your person, the architect or architectural team, and they are thinking a lot of things. You got your emotional side to it, you got your inspiration, and then you got your engineering, and then you have all your specialities. You have your structural input, MEP, your landscape, and all of them. Many times they're working across probably across different time zones. And so you use the internet a lot to get your input. And your contractor also comes up with shop drawings, depending on what needs to be fabricated, perhaps in a factory and then brought to site. And then you create a nice 3D model. And from this 3D model, you actually extract two-dimensional drawings. So you can see this very important link here. And over the time of the construction of the project, you can, using this database, your three-dimensional database, you can add the remaining information fields and add your timeline, which includes every aspect of construction, as you can see here. And then you can have your costing going in parallel with this. And the whole purpose of using BIM is to bring down the cost and bring down your construction timeline. And further to this, you can do your facilities management over the life of a building. All kinds of maintenance tasks will come. Sometimes you can even do additions or phasing. And over here, you can do your, based on the weather, you can do your energy management, your response to your surroundings. And even there, you can use your BIM to bring down the cost of energy, you can bring down the cost of maintenance, and other fields that follow. So this diagram sort of gives you an idea of the interrelationship between all these so-called BIM dimensions. And it doesn't stop there. You got other fields of information, such as sometimes referred to as BIM 8D, occupational safety and health. And today it's becoming a big topic, especially your indoor air quality, your warfare, your germ warfare that you're trying to fight. And sometimes you have crowd control if it's large gatherings of people. So it could be a part of 8D, because again, you're talking about occupational safety. But they are very specific to stadiums and metros, where large groups of people who are not familiar with the place, they come and go. And it's not like an office building where you know your way around the building. So your crowd control is very important. It is a field of study that may be a part of your building design. Planning during your building design. Then you have dynamic buildings that can change their shape, form, and location. There is no specific dimension for this, but it could be another aspect or a field of information that you would wish to consider. Then you have embodied energy. That's another field that people talk about. How much energy has actually gone into making this building? You can say, I've added solar panels, but there's a lot of energy that goes into making a solar panel before it can even produce 1 watt of energy. So what is that's embodied in it? And you may wish to add that into your the energy used in your construction process. Water recycling and management, another field of very important field of study. Then also associated very closely with buildings, which I think should actually take more precedence in an architect's scheme of thinking, landscape elements, which typically clients think of it, or everybody thinks of it as an afterthought, but it should be very closely integrated into your design, and because they can grow and change with the seasons. And of course, in India, we don't have that dramatic change of season other than monsoon and non-monsoon seasons. But in other temperate or higher latitudes, you do have very distinct seasons. And all the other topics that we saw in this webinar series, which includes your cloud capture, point cloud capture, your artificial intelligence and big data and 3D printing or Internet of Things, so many topics we saw. We did see digital fabrication, VAR, VR and AR, and we also saw some use of robots in construction. All of these can be modeled. And you saw examples of them, some really powerful examples, and they are at the way beyond what most architecture practices do. And you could see them using BIM in some fashion, in some form or the other, And they never talked about BIM dimensions. They just did their work, and simply consider these as a one-off input or output to your BIM. Then one of the things that we have not escaped from, and I don't think that's going to change anytime soon, probably until robots take over construction, until such time, is the construction document set. This is probably very important. I know that students in the audience today will be seeing design more in a very emotional manner, but the engineering of it and the drawing production is very, very important, because that's how you convey information to your contractors, and they build from your plan. So even though you have thought things out very clearly with the BIM, you still end up producing orthographic projections of all your plans, elevation sections from your BIM. You can do all of that from your BIM. And then, of course, there's a touch-up process for that, because again, I'll get to that where BIM cannot, maybe you don't want to model everything in BIM because of the detailed work that's involved. And then to these drawings, and you add your construction notes and your technical specification documents. So from a BIM 3D, or which you can consider as a BIM 3D database, you extract a whole bunch of 2D drawings. And that remains a primary deliverable. We can't escape from that at this point in time. All practicing architects in this audience, I think, agree with me on that. And even though sketches are there, you still go to site, you can still show them, but the BIM can be used to make people understand, make the contractors understand what you wish to get done, but eventually he's going to look at the drawing. And prior to the evolution of BIM as we know it today, you did have a lot of very good visualization tools, and they are all still around, and you used 3D CAD. And this allows you to record and share what you imagine. And software such as Autodesk AutoCAD and Bentley's MicroStation. I think earlier MicroStation was called Intergraph, and I don't know if they purchased it, but AutoCAD and MicroStation were the mainstays for drafting your work. And you used 3D primitives such as cubes and cones and donuts and spheres, and then you added vector-based entities that you sweep them across paths, and you created really complicated solids and surfaces to express your building. But these 3D models have limited real world properties. I mean, you still have software that can augment those into more intelligent models, but they were not designed from the ground up. But they could be photorealistically rendered and used. They were very good visualization tools. Like today, you still have Macs going around, and those in the who do not want to use Macs, there's another tool called Blender, which is very widely used for rendering purposes, even in the film industry. So you have these 3D CAD models. For example, I'll show you one model that we did many years ago. This is a mechanical engineering model. It was for the DRDO. They were many years ago. They were planning to. They were still planning at the planning stage of making what is known as a scramjet, which is beyond ramjets, and they can go beyond Mach 5 to Mach 10. And they wanted to test. This was a test bed for that. And all the equipment you see around were designed to produce the kind of airflow required at those very, very high speeds. I'm talking in excess of 1,500 miles an hour or 2,000 kilometers an hour or something beyond. And you had this cylinder that you see here, that was your test chamber. To give you a sense of scale, that must have been about 10 meters long, about 3 meters in diameter. And all these things were various combinations of compressed gases that when combined sent a jet of air here. And you can see the very long exhaust here, and all these were housed in separate buildings. I'm only showing you the CAD model that we created, even though we are not mechanical engineers, but we are good at modeling. So we did this, and the reason I'm showing you this example is to show you that it's just a dumb model. It did not have any capability to actually do airflow simulation. It did not have any material properties. We did not know what pressures it could withstand. It was more to define a concept. and to explain to the scientists at DRDO what the proposal was all about. And as an extension to this, you would be happy to know that India is only the third country in the world to actually design and test and actually fly a scramjet engine as of 2019, after the United States and Russia, today Russia. And other countries do have the expertise, but India is only the third country to do all of this indigenously. So while we do have CAD software that can help us build very complex models, remember its entities can be made, can be given material attributes, and it can be made to show that it's an intelligent model. But remember, it's a shoehorned in process. That means it was not designed from the ground up as a native virtualization. It was more of a modeling tool. And today you have AutoCAD Architecture. Earlier it was Architectural Desktop. It's still marketed by Autodesk. And there are companies that still use it. And there was always, in fact, in about 10 years ago, there was a lot of debate about, I have Architectural Desktop, I have AutoCAD Architecture, and why do I need BIM? And then slowly you started to see the effect that BIM can have on your, the extensibility of BIM is much more powerful. So because with BIM, you can place digital twins in a virtualized world, and your model can be made available for others to experience and extend their properties. So that was very important. So you could design your BIM, you could design the model in such a way that other disciplines could add on to that. Here is an example of, earlier I showed you just a CAD model. Here is an example of a BIM. So a entire house, from every floor, all the elements that you see in this floor were defined in their construction roles, whether it's RCC walls or stone walls or stone cladding or glass, you name it, whether what flooring we used, what furniture layouts we used, what lighting we did, everything was modeled in this building. And all the floors, including the solar panel layout, was modeled and built exactly. I would say almost exactly, because we did do some changes at site. And today that building is seen from the BIM, almost exact replica of it is now built. Other uses of the software that we use, in this case, it was Revit that we had chosen from Autodesk many years ago. We suddenly discovered, to our happy surprise, that you could do a lot of in-house renderings, you could do simulations, you could do interior materials. Here we retrofitted a bar and a dining space. Then we also did the usefulness of BIM is complicated roofs like these. We were able to work with the contractor and give him the exact cutting patterns, because you can see the complexity of the roof here. We're able to do production, not really shop drawings, but we were able to extract the shapes that the contractor then went and made easily. He was able to make shop drawings for a roof, complicated roof like this. And then we also did lighting studies. This is a rendering of an interior of a restaurant. And then we were able to photograph it after it was built. And you can see that it did represent, the cove lighting, the wall washers and things like that. We were able to give the client an idea well beforehand. And the end result was did closely match the design intent. And these are some of the usefulness, and all this was done within one model. It was not external software. It was not like you did something here and then exported it to something else. No, everything was done in-house. Here we ran into some problems in the early days where we did not, in those days when Revit was, when we started using Revit, we did not have any knowledge of Rhino or the Grasshopper. So doing these difficult elements, such as these tapering walls, everything was crafted manually inside of Revit. We didn't have, like, we wanted rope around wooden beams, and we had to manually create them. There was no library, there was no family of content. Everything that you see in this model here, apart from the furniture, were all handcrafted. And so it was a very difficult process, but we still managed to, because we understood how to create these entities, we were able to do it. But today you can do these things much better. I think the next generation of architects who are familiar with programming with Dynamo or Rhino and Grasshopper will probably be able to knock this off very, very quickly once they know the requirements. And then also inside of Revit, I keep bringing back Revit because we depended a lot on Revit, even though there are other tools in the market. We found out that we could create very, very quick and dirty animations. You know, you don't have to render completely. You just model your environment, your terrain, and then you run a very quick. It's not a very smooth model. Look at it; it's just 150 frames, but the client is able to get a very clear idea of how his resort is going to look. Right. So even we have not put any materials on the walls or roof design. We have not done anything. We did a few more 100 frames like this and did a walkthrough throughout the property, and the client was able to get a pretty good idea. And then they gave us the okay for going ahead with the next level of rendering. Another project that we did I'll give you an idea of how quickly this happened. We started on a Monday and worked through the week, and the following Wednesday we were not 3 days but 10 days, 9 days later we were ready with the presentation. And this was a central administrative building, almost 30 floors tall. And from the time we studied the client requirement to understanding the bylaws, the various options various planning options, to creating models, plans, renderings, and solar studies. For example, we were able to do, because the building orientation was not exactly north-south, we were able to study the effects of solar gain, and not just lighting studies, not just whether it's light or sunlight or shaded, but actually get the energy values. We were able to do all this in about 8 or 9 days and make a presentation very quickly. So you have some very powerful tools packed into software, and able to do things that you were not able to do earlier with such speed and clarity in thinking. It frees you to think more deeper into the subject, and allows you to do a lot of what if scenarios, and give the client more options in the very first week or so of the project, which is a very powerful time in a project. The decisions you make in the very early stages of a project sort of cascade throughout the design, and becomes permanent. So the tools like that are wrapped into Revit and software like this help architects see deeper into a project very early into the project. Here, for example, we did a neighborhood study. There's a big main road here. We were able to do multi-use complex here, which included shopping, theaters, and office buildings, and then a lot of residential spaces. We were able to do a lot of configurations of these residential spaces, open spaces, your footprint. We were able to do climate modeling. Understand, that maybe this is not the best option. Maybe it is. Maybe you need to rotate some buildings. So all those things we're able to do very quickly and present what if scenarios, and even the ability to put them on Google Earth and show them in context to their surroundings. Make these tools much more useful nowadays. So coming back to the actual deliverable that again I mentioned, which is the mountain that most BIM adopters find hardest to climb, are your working drawings, right? Your working drawings and your good for construction drawings. These are your deliverables. So it becomes very, very tough when your consultants are not on the same page as you. And we have had our share of problems whether it's structural or MEP, we sometimes simply don't get the support from them. They still continue to work on their own, in their own way. They still produce AutoCAD drawings, and that's fine to a certain point. But when you try to integrate into BIM, then you find that there is a shortfall. that in your office, you will not have the structural expertise or the MEP expertise to model all those elements. Our structural engineers do their own thing. They have their own software, and that's also fine. But nowadays, you do have links between the kind of software, the tools that structural engineers use, and you can go back and forth between your BIM and the structural engineer's input. But in an architect's office, a unified BIM for a project is rarely seen unless you've been working with very large builders or contractors, somebody like L&T, for example, and the afternoon speakers will probably speak more about this. Large builders are able to invest very heavily in BIM and completely tie up all the disciplines into their model, because they are the ones responsible for building it. See, in India, you have most of the projects are item rate contracts, right? The contractor quotes a rate for a certain item in place to be put in place, and then you give your best effort to make a quantification of the project. But in many Western countries, they call contractors to bid, and the contractor is responsible for providing a lump sum bid. So the contractor then takes the design and completely engineers the entire project in BIM nowadays. And they are able to see the complete workflow, completely able to see when materials come and go, what is the waste, how to minimize the waste, how their workers have to move in and out. And they're able to minimize their losses, construction losses. The usual construction losses are minimized. Even if you knock 2% off the cost of a project, if it's a $100 million project, that's $2 million saved. So that's the scale of operations for a contractor to completely invest in BIM nowadays, and that you do not see in an architect's office, because architects don't work on those scales. Most of the architects, only maybe there are half a dozen architects in Bangalore who probably have invested very heavily or gone very deep into BIM, where all the disciplines are covered. So majority of structural design, of course, you know that most of the design, at least a majority, is in RCC design, and most of the structural engineers work with software such as ETABS or StatPro, and sometimes they use StatPro even for steel design. And then they have offshoot software for that, such as RCDC, to create your CAD output. So they give you AutoCAD drawings at the end of the day, and there is no cross-pollination between the way they do the work and the way you receive and change information. Many a time what happens, they give you the sizes of the finished column, and then you input just those sizes. You don't even know what reinforcement they are using. So yes, there's a tool called Robot within Revit, and there are no structural engineers that use Robot. So they are all trained in ETABS. And so now ETABS does have a linking tool to Revit, for example, and even StatPro. So they are able to link back into your AutoCAD. Before AutoCAD, they're able to link back to Revit. And then before you produce your AutoCAD output or a printout for the contractor, you are able to do your bidirectional data transfer. But that's just happening. So I don't see many architects working on it yet. We are still struggling with this. We have not yet mastered it. We are on. Of course, it'll take a couple of years. And MEP consultants, that's another big issue here. Also, they provide mostly SLDs or what are known as single line diagrams. They specify, they draw a dash dot line and then say that this is a 150 mm diameter pipe, and then you find out that what they mean is the internal diameter, and then the wall thickness you add, it becomes 156 millimeter, and then where one pipe couples another, you add another coupling diameter, and suddenly you're looking at 170 millimeters. So these kind of things are not drawn by the MEP consultant, but become very critical when you're dealing with tight spaces between, say, a false ceiling and a RCC slab, or a steel construction, or you're sending pipes through castellated beams. So these become really, really difficult to work with when you don't have a model. And then you end up with people shouting at each other on site. And therefore, while there is still, CAD is still a good source of documentation, it doesn't see as deep into a project as a BIM does. And we encourage, architects to work with MEP consultants who ask them to train their staff to go and understand how to model these manufactured products. Many a time these are manufactured products, even though a couple of days back we saw one of the architects work with natural material like bamboo, and you saw how they were able to approximate their model and still manage to create very complex buildings. Here is a classic example that we faced. Okay, this is an apartment housing complex where the design master plan was done by a British architect, and then the local developer appointed us as the local architects. And the model that they sent us did not even work because they did not understand our local bylaws. By the time we finished going through their design and recreating everything in Revit, the structural engineer, meanwhile, was trying to analyze the shear wall construction or shear wall system in a separate platform. So you have our Revit model completely independent of the structural engineer doing his own ETABS or StatPro model, whatever software they used. And while we were involved in all the bylaws related to planning, the builder or the developer did not have the time to wait for us to completely finish our studies. He wanted a brochure and he wanted renderings. And so he went to an external, these artists who do these models, and whether they use Max or Lumion or whatever they use for creating their renderings and animations. This project actually ended up being us doing a Revit model, the structural engineer doing the same building in a different software, and the builder going to an artist who used a different software, all from scratch, and complete waste of time. But this is what's happening. And we are trying to close this. We are trying to close this. We know that you can achieve this from this. We know that you can achieve this from this. But the knowledge base surrounding us is actually limiting us. So this is something that I'm expressing to you in the audience. And I'm sure some architects may have cracked this and found a formula to come over this, but it may not work on every project because the resources that are required to do this require a very healthy computing environment. Here again, every time we try to do, this is a building design, we completely redesigned the frame exactly as per the structural calculations, but this frame was not used for structural calculation. Same here. All of these projects where we rather reverse engineered our building to include the structural input. Sometimes we included MEP. We started modeling MEP elements into our building. This, for example, the factory that we designed, and this is the finished product. This is a building in Chennai. This is a concept design. This is a school in Mysore, and this is a part of that. And then all of these buildings went through this fragmented process. We did not do a unified process. We are trying to get there. Here, for example, we started modeling these elements, the MEP elements, for example, all this piping, and detection. So we found out that this pipe, when it goes, the way the MEP consultant had drawn the SLD drawings, and then when we modeled it, we found there are clashes. This would have ended up as a shouting match on the site, but we caught it early on, and we managed to make this clash not be a clash at site. So this is a very simple example. There are many complicated examples of MEP clashes, and this is not a clash of MEP with structure. It is MEP with MEP. So and both of them are in the sanitary lines. So it's not even between a water line and a fire line. It's or an electrical conduit. It's just one drafting guy in the same discipline making a mistake like this. So you can imagine the kind of confusion that happens when you have 6 different disciplines trying to get their work done at site all at the same time. And most of them, what happens is they all land up at the same time at site, the last 3 months of a project. So that's when you have the real, project management consultants, for all they claim, there are very few of them who have the expertise in all of those disciplines. Okay, so here, this building, all this entire back wall, we modeled. All the piping that you see, everything was modeled by us to ensure that there is no problem. Even the solar panel layout, the water tank layout, the air conditioning layout. This is a drone view of that solar panel layout. This is again a drone view of that building. So we were able to create, even though it's not a big building, but we're able to detail out every aspect of this building, including where the generator should go, where the electrical installation, your air conditioning, your internal, behind this wall, there's a duct. We model everything. Okay, here's an example of a very complicated pipeline layout. Here's its CAD model. This is something I saw in Finland. The contractor is one of the world's leading contractors called Skanska, and they had actually implemented BIM in a very highly accurate methodology. That's something that yesterday's speaker mentioned, to 2 or 3 millimeter level accuracy is what these people had implemented, and this was more than 5 years ago. And when we saw this junction, the engineer who was showing us around, I said, "Can you show me this in your?" He was carrying a tablet with him, and what these people had done is they had a GPS for the building, and inside the building they had micro GPS. That is, it would allow them to go within centimeter or millimeter level accuracy inside the building. And he was able to stand here and show me this on his tablet, what was constructed here. He said this was not there because this was what was given. They redesigned from the architects' models and the MEP designers. They re-engineered the whole building in their CAD model to their codes, and they're able to do this with hardly any mistake. Okay, the level of detail, I'll come to that a little later. I asked him about these hangers. He said they did not model these hangers. These pipe support hangers that you see, they decided to skip that. They said they will do that on the site, but they wanted the major elements in place. So in your discussions on BIM, you will always come across this discussion on how detailed should your BIM be, or in other words, what I term as granularity of your model. How detailed should your model be? And there are terms that are used, thrown around in the profession, are LOD, or sometimes maturity level, in relation to BIM. So what does LOD mean? We'll come to that. First, I want you all to look at it as architects. What do you do to deliver the documents related to your project? You have maybe a concept and a schematic, preliminary design schematic stage. Then maybe there's client approval and statutory approvals. And then you have your working drawings. Sometimes your statutory approvals, I would prefer that statutory approval come after working drawings. But then many clients want their approval process to be in place before they commission the rest of the project. So we end up all the time with a slightly different building than what's approved. Then you have your final stage, which are good for construction to issue to the contractor. And these are the normal stages of drawings. And when you do your drawings, you also change your level of detail. And the two terms for LOD, the acronym LOD, people throw this around, is LOD is level of detail or level of development. Now, the two are not the same, but are frequently used interchangeably, and I'll specify what they are. In level of detail, I'd like you to relate back to your drawing. The drawing that is sent to the contractor, drawing that's sent to the site, or drawing that you send to your client to understand the project, they contain different levels of detail. At a schematic level, you really don't bother with too much of your plastering lines or door frame, exact door frames and things like that. You just indicate a door. So level of detail more pertains to the drawing. Level of development is your model, your BIM, in which you craft your model to such a level of development that when you cut a plan from it, it shows the level of detail that you wish to show. So your level of development is in the model, and your level of detail is in the output, your drawing output. Okay, so that makes it very easy for people to understand. So these levels of detail or level of development correspond roughly to the architect's stages of work. I'm not going to go into the definitions because the definitions are long-winded and boring. And many people have written reams of pages of information regarding what LOD should be. And by the time you read it, you will not make heads or tail about it. And therefore, it's very simple to put them in a diagrammatic format like this. So when you do a concept, right? When you do a concept, you do your preliminary, either a single thick line or just 2 lines to represent, say, a wall. And that I would say that's your LOD 100. Okay. Now they're given grades of level of development from 100 to 500 and in between numbers. And when you go into schematics or for approval, you may shade that wall as to indicate it's different from a window. And then when you go in, that's say level LOD 200. Now, those who are very well versed with BIM know in more detail what I'm talking about, but don't worry too much about the exact definition. I'm trying to make it simple for everybody to understand. And for working drawings, which sometimes can also be good enough for construction, even without plastering lines, but as long as you show the material, you're putting a hatch pattern, whether it's a concrete block wall or whether it's a brick wall or it's a stone wall. So then you start, let's call it LOD 300. And then when you actually issue good for construction, you worry about your plastering lines, you worry about where the plastering turns into a door frame, or is it a plastered opening inside which you fit in your window. There you can call it a good for construction level of drawing, which is your LOD 350. And then you get into really deeper and deeper levels of detail. And then this, for example, here is a brick wall in Flemish bond, which needs to be exposed from the outside. You should see the bond, and from inside you can see you don't need to worry about seeing the bond. You're going to plaster it anyway. So here you have your internal plastering line. Here you have your external, your pointed joints. And then you can also indicate, for example, that since these are the only bricks that are seen, the brick inside need not be a wire cut brick. It can be a table mounted brick, so that you say 1/3 of your bricks are not necessarily wire cut bricks. You can lower the cost. So at your LOD 400 level, you will be getting into details like this. Okay, so I hope that should sort of clear people's doubts about what are levels of detail. And this is LOD is something that is probably more leans towards the AIA or the American Institute of Architects. The British or the RIBA documents start talking about BIM maturity levels, and they talk about maturity level 0, 1, 2, 3, and 0 is more like drawings which are simply drawings like CAD drawings, or even hand drafted drawings are considered as maturity level 0, and maturity level 1. There is some attempt at BIM, but there is no real world information made into that solid model or the 3D model. And then you get into maturity level 2, and in maturity level 2 you start talking about all this interoperability of BIM. And maturity level 3 is still going under a lot of redefinition, and it's made into subsections A, B, C, and D. We don't know when this will end. It's an evolving field. So it's a moving target, and therefore you can expect these definitions to change as we go along. Okay, here's another example of LOD. It's a very common example given in most documents about BIM. LOD 100, for example, shows a column, just a block, rectangle, and LOD 200, you now decided that it will be a steel column, and therefore it's going to be perhaps an I section. And LOD 300, you actually specify the thickness or the strength of that steel column, and therefore the actual section to be used, ISMB or ISA, whatever is the section available in the market. And then LOD 350 will show the base plate and the anchoring of that base plate. LOD 400 will show even the nuts and bolts. Okay, so this sort of gives you an idea of what LOD 100 to 400 is. And you may ask, now I mentioned up to 500. So what's 500? 500 is, LOD 500 means that it has been executed and verified at site. You can think of it as your as-built drawing set. Okay, so many architectural practices have embraced BIM in one form or the other. Now, if you're new to it all, to BIM, you will say, how do you choose what path to take? And then your very next question is, wait a minute, what do you mean what path to take? Isn't there a ready-made BIM solution? Isn't BIM a software product? And there are no simple answers for this, because BIM is still an evolving field and there are many players in the market, and this will sort of give people an idea of why it can be confusing to someone new to it all. And you can see, for example, here's your BIM landscape. All these are various companies, or sometimes one company introducing many products into the market. Over here, you have conceptual modeling. Here you have data capture. One of the persons in I think the very early webinars spoke about data capture. And then you have parametric modeling. Again, a couple of days back, we had a very, very important talk about parametric modeling, and then you have design authoring. How do you output this into an information set that can be used in construction? And then you have this complex set of people, a bunch of people who manage this data all the way to your site. And how do you, these are all collaboration tools. And then you have fabrication, actual work happening in a workshop or at site. And then before it goes into an actual design, you have environmental concerns. Environmental concerns could be both in regard to the finished building as well as in the construction process. And during this whole process, you have this clash detection, which sort of is like your proof checking. You know, when you write a newspaper article or a book, you always have it checked. So this is your proof checking at this point. Make sure that all the errors are caught before it goes for printing. Then it becomes very expensive. And then you have your visualization, right? You have various ways of visualizing your building. Sometimes you actually construct the building. Sometimes you actually just view the building, what yesterday's talk was all about. And so over here, you have the sea of software. For example, you can start your modeling with SketchUp, or you have Format, or you have Inventor, and then you have your parametric modeling tools. SketchUp is also can be considered as part of this family. You have Grasshopper running on, working with Rhino, and nowadays it's tightly integrated into Revit. You also have Dynamo, okay, and then you have so many. You have Navis works for clash detection. Then you have output in the form of AutoCAD. It could also be an input. You could have design authoring go out as an output, as a drawing, or you can also have it come in as an input here. And then you have Bentley systems. Then you have Revisto for understanding how to extract the data. And then you have this one is an example, Ideate. Ideate is a company that has many software tools for monitoring the project. And then of course you have your communication with Outlook and Outlook Calendar. And so many such tools. Then you have another tool that is used in project management is Trello. And then you also have robotics, which here's one tool called KUKA. Then yesterday we saw that you have virtual output. You have software that you can use for, like, you use V-Ray rendering to work with 3D Max. So you have so many such tools which really make a person entering the field feel overwhelmed, and it's very not easy to start. Most people who are starting with AutoCAD, what happens is, because you're not already an Autodesk customer, you make the jump to Revit. Sometimes many students I've come across are very good at SketchUp modeling, but then what? After SketchUp is done, once you do the SketchUp model, what next? How do you make it? How do you engineer from it? It's just otherwise it's just a pretty picture. So you definitely need these tools to author and understand your design process. Here I have not even mentioned the structural design process here. I'm only talking about BIM as seen from an architect's eyes, and so many experts are there in so many other fields. It can't be done by one person. It's just not possible. Okay, so this is a very confusing landscape, but I will show you how to streamline it. Okay. And for example, here I mentioned virtual, you can do VR for viewing. Here's one architect's office that I visited in Finland. The architect's office actually had a visualization chamber. It's called a cave, and they put 3 huge screens slightly angled from each other, so that it gives you you can see that line here. That sort of gives you a very 3-dimensional view. The screen is blurred because it's a 3D projection. That means it's a split image. So you wear 3D glasses, and when you stand here and walk in this mall, it's it's a little disorienting, because the ground doesn't, when you walk and the building moves, it doesn't move exactly the way you walk. So it does feel a little disorienting. But it is quite real. It does feel realistic. It does give a sense of scale. It does give you a sense of space, but you can't use it for long. I tried it for about 10 minutes and got dizzy. So it's an expensive thing. You need some very good 4K projectors, and so that the resolution is good enough to seem real, even at this very large expanse of projection. So all this is output from BIM. Okay, it's how you use it. Then one thing to remember is when I said, when architects say, how do I, what do you mean it's not a software? Well, it's not a product. That's what I'd like to say. BIM is a process. Okay, it's a bunch of tools. You pick and choose what works for you. You decide whether you will stay with up to BIM 3D, and maybe you do your energy modeling and don't worry about your project phasing. Don't worry about costing today. It becomes very, very overwhelming on day one to think of all of it at once. Okay, first is just to learn to model properly. Okay, then there is no single universal BIM product. There is no single universal BIM format. Even though there's a standard called the IFC or the industry foundation classes, and that sort of sets the tone for the database restrictions that you need to follow so that you can create a model in Revit and view it in some other viewer, or manipulate it in some other software. So ISO is trying to set standards for this. Again, when you read a standard, it's very difficult to understand the words because the standards are so long-winded. It's not easy to figure it out, to figure it all out, to understand the scale and scope of BIM and put it in a document is very, very difficult. Okay, so there is no single format, but you can choose a format and stick to it. Now, there are vendors that supply some, maybe not all, but some of these processes in a proprietary format, such as Graphisoft produces ArchiCAD, Autodesk has Revit, Bentley Systems has its own. There's a whole suite of products from Bentley Systems. So with SketchUp, which is now owned by Trimble. So you have these huge companies. You rarely work with all their products. Yesterday, you saw one of the presenters give a very, very detailed description of the kind of software and hardware that he uses, and he warned you that they are quite expensive. Now, there are others that follow open source protocols, are quite less expensive, and surprise, surprise, may also be free. ACA, for example, has a suite of software known as Edificious, and they are quite affordable. But I don't know if anyone's using it here. I just know about it. And FreeCAD, very surprisingly, FreeCAD is quite a complicated CAD tool. It has many workbenches, as they are known as, and you can install a BIM workbench, and you can actually do a BIM. You can actually create a model, an intelligent model in a tool called FreeCAD. It's completely free. Anyone can download it. And I'm surprised. I'm really surprised that such a complicated tool is free. And it's completely based on open source software. Here, about 10 years ago, somebody created this, I think it was about 2012 or 2013. This was a landscape then where Rhino, the person was probably an expert in Rhino, because Rhino has very, very good tools for creating complex geometry. And today it's interconnect. Today, Rhino fits into Revit. And from Revit, you had Revit purchased Ecotect. Autodesk, actually, Autodesk purchased Ecotect and integrated into Revit. And then you're able to do your analysis. Here's your drawing documentation coming out finally in AutoCAD. And you have your presentation workflow using Photoshop, V-Ray, PowerPoints for communicating your ideas. You have other parametric software such as Rhino and Grasshopper. And over here, you have your 4D and 5D workflow, including software such as MS Project or Primavera and things like that. Excel, of course, highly underrated software, very, very powerful if you know how to use it well. And then your fabrication workflow such as 3D printing or physical models or actually putting up a building. So these are the kind of workflows that you see if you try to be in one type of platform, a Microsoft, Autodesk, Adobe universe. Okay, that gives you an example that you don't have to go all over the place. You can sort of wrap it up within one. Now, choosing to implement BIM, okay, requires investment other than the usual capex. What I mean by this is that the firm that's decided or builder or whoever decides to implement BIM, it needs to come top down. Yeah, otherwise, what happens is once it becomes something that somebody else does, and if the design team or the architect who is running the show does not understand the process, then it becomes very divorced from your design proceedings. So you end up telling somebody what to do here and there and not get involved. That's okay, that's a way to do it. But what happens is it may end in disillusionment if and when that expert or the person who has done all this work, if they decide to change career paths or go somewhere else, and then you will end up going back to your tried and trusted AutoCAD. And this has happened before. I've seen it happen. It needs some involvement from the proprietors or the partners in the firm. Okay. In the longer term, despite the cost, there is a very good payback for when you use BIM. You have really fast project turnaround times. I gave you some examples of some very complicated presentations done in the matter of a week to 10 days, which would have in otherwise been very tough to make that quality of presentation. You can do very quick discussions with the DWF output. DWF, it's there in Revit. You can output your model. And I'll give you an example. I'll just stop the share for a second, and I'll show you a couple of DWF outputs which we use when we communicate our ideas with clients. Nobody needs to have any complicated software. You just export the output, which has all the elements that you wish to include in that output. And I will just stop the share, and I will switch to that screen. Okay, I hope everyone can see this. This is...
So not just yet.
Not yet? Okay, 1 second. Now?
Yes, sir.
Okay. So this is a multi-use site. It is in Zambia. It is in Lusaka, Zambia. It was formerly a prison site. This whole area was demolished. All this area was earlier a prison. It was in the heart of the city. So they knocked it all down, and it's a government land. So the government has decided to lease this out, and a developer who was working on obtaining the lease is still working on the lease. But meanwhile, we have completed the presentation for this project. This includes some mid-level, mid-rise housing, some exclusive residences, a huge play area, and a clubhouse development. Over here, from another very main street here, they have a hotel, a convention center, and a commercial building with a high-rise casino, with a tower casino that you can see. So this entire project, which we were able to do very quickly. Of course, the concept took us about 2 to 3 weeks to understand, because again, local requirements. Understand, we have visited Lusaka, we spent some time with the client, we spent some time with the developer, trying to understand the kind of housing. You can't just make a housing, you need to understand their local desires. And we worked with a local architect there to get some typologies that they would like to have. And also because it's in the southern hemisphere, your solar calculations, what's summer and winter, everything slightly changes, because of the angles of the sun are slightly different from what you are used to in the north. It's a mirror image, of course, and the seasons are opposite. It's not that far from the tropics, so it's not so dramatic. And we were able to turn this around, and these kind of models were what we shared with the client, long distance. And this was way before our Zoom became so pervasive, and everybody knows how to do a online call. So we were able to send these models to them, and they don't need to pay. They don't need any paid software. This is a DWF output, which can be read by a free Autodesk software called Design Review, and they can open this model. And they can rotate this model, they can cut sections, they can do walkthroughs, they can zoom in, they can zoom out, and it's a very simplified model. Even though our BIM would be very heavy file, the DWF output is much thinner. It doesn't occupy that kind of disk space, so it's easier to email to somebody and have them receive and open it. And so DWF is something that we work with quite a lot. And I'm just showing this to you as a means of understanding how we communicate with clients. And today, of course, you don't need anything. You just need to have a Zoom account, and then you can all log in, and I can present it to you. But those days, a few years ago, it was not like this. and not so easy. Even Skype was a little rough around the edges when we did try Skype many times. But always internet access decides how good the interaction is. So we used to mail these around to our clients and teach them how to use this software, and they are able to understand very nicely how to do their own exploration of the 3D model. So I'd recommend this for architects. I will show you one more. Earlier, I had showed you one building, which is here in Bangalore. And even this, for example, I hope you can see the changed model now.
Yes, sir, we can.
So here, for example, it's a very simple building. It's a very small building, but we are able to show the client how to, they can do their own walkthroughs. They don't need expensive software. It becomes when the clients themselves on an ordinary computer, it doesn't have to be a workstation class machine or anything. With an ordinary computer can do this. It gives them a whole sense of freedom that they feel that they are participating with their architect. And they find, okay, this is their parking area. We did populate with cars. I'm showing you a much simpler model now. So this was one of the stages of the design, and we can keep going floor by floor. We can examine all sides of the building. All architects are used to this, but clients are not. But once we give the client the hands-on approach, it makes them feel very satisfied that they are working with an architect who knows what he's doing, right? So this is their office space, and then we did an interior fit out and showed them how this can also be fitted out. So all these things are possible with exporting to DWF and sharing the model. Very simple with no real specialized software, just design review from Autodesk. Free download from them. Anybody can use this. I recommend this, and I'm showing it to you in grayscale. You can view it in color. The colors are not realistic though, so that's why I stick to grayscale when I do this, because it doesn't match your rendering. But it allows you to study the form and design. Over here, for example, all the pipe layout which we studied with the contractor, all that was done here. Our air conditioning layout, our electrical conduits. We even had underfloor air conditioning. Everything was studied in this model. This model kept getting populated, ripped open, added, put back, and you can make notes on it. You can put annotations, and it gets recorded just like your. If you have a PDF document and you're annotating the notes that somebody else wrote, and then they get it corrected. Same thing here. It's like proofreading your building. And the engine, this DWF engine works on the same engine that Navisworks uses for clash detection. So it's a very, very complicated software packaged into a very simple user experience. So this is something that we like and we prefer to use and discuss with our clients. I'll go back to my slideshow. Okay, so quick discussions with DWF. Clients understand the 3D models, interactive 3D, much better than drawings. And we found that DWFX was, FX is a later version of that. We found that the DWF format is a very, very useful format. You can explore with it, the options with it whenever you feel like. And it gives you, BIM gives you greater control over changes. You make a change in one, all your drawings get updated. You change your door size, your sections reflect that. And one model can be shared among multiple participants. You can choose, which phase of the project they can touch, or just the other phase of the project they can view. Output in the form of drawings, 3D printed models, and virtual reality options. All these give you the payback. Is not easy to calculate what's your payback, but it really makes you a more powerful architect. Okay. So these were some of, I'm showing you these buildings in DWF because they share a similar viz engine with Navisworks. And in the computing environment, okay, in a Windows, in most architects' offices, you will find that a Windows environment is typical. Right? Most people use Windows. The networks are simple, about 15, 20 computers. or maybe not more than 50, and larger offices. And there are a few, there'll always be somebody more artistic or who prefers the features that are found in a Mac operating system. But then you may be limited in using Macintosh computers because the software may not work on it. And again, using a dual boot machine, not everybody is well versed with that. And Linux, again, Linux workstations, very powerful workstations, but you may find more of these Linux machines on the server side rather than as a workstation. And you will find that as you see and look at the various software in the world or around you, most BIM software suites lean more towards a Windows environment. Although in a Mac environment, you could happily use ArchiCAD. In a Revit world, you will prefer a Windows environment. And these are very, very important investment choices, because it's not something like you buy as a mobile phone and use it for a couple of years. Most of these investment choices will have a repercussion, and they last for very long, run into years, and maybe a decade or so will be your investment. Some of the computers will last for 5, 6, 7 years if you can keep cleaning it up and upgrading it now and then. Because it's not easy to change your computing environment. So you need to study this and make a informed decision. You'll need, for BIM, very plain and simple, you'll need workstation class machines to create a comfortable BIM environment. Otherwise, you will, most of the time, if you use ordinary consumable laptops and computers, you will end up with limitations. For very simple models, it may work, but as you get more and more complex and start to do really heavy objects with thousands and thousands of parts, sometimes runs into hundreds of thousands of parts in a BIM, it starts to become quite heavy. And you will need to really invest in those machines that work in a BIM environment to be workstation class machines. You can still have your simpler machines doing AutoCAD line work and things like that. Another recent problem that happened last year is that while we have a lot of desktop workstations, when the lockdowns happened and we had to send everybody home with those workstations, it was a very, very disturbing time for us, just packing all those machines, sending them to different people's home and bringing it back 2 months later. It has caused us to change our thinking. In future, we have decided that we will never buy another desktop. It's always going to be workstation class laptops or just good quality laptops for other users. So that's something that has changed. It's pound for pound, a laptop costs more for the same computing power, but it's really worth the difference in cost. It may cost 10-20% more, but the portability makes it worth it. Okay. So here's an example of what I would consider a workstation environment, a production environment workstation laptop. There are many variables. So people are always confused as to what I should buy, what should I add. So depending on your workload, you choose a laptop, a workstation class laptop, which is, don't go for the really big screens, 17 and or very heavy machines they are, and 14 and below are very tight to watch. 15.5-inch laptops are probably your perfect dimension. Don't worry about touch screens. When you're working on BIM, you rarely use a touch screen. I'd rather that you have graphics cards that can output to multiple monitors. Then processors, again, you have i7s and i9s nowadays. Quite expensive i9s are, and Xeon processors, or in the AMD family, you have Ryzen's 7s and 9s. And always more cores, the better. You get 4-core processors nowadays on laptops, workstations. You're getting 8-core processors, and the CPU. You spend your money on the CPU. Don't hold back on it, because that's one thing you can't change. You can always go with lesser memory and lesser storage, and then add them as you go along. But your CPU is somewhere. There's one place where you make sure that you get what you want for the kind of work environment that you need. So 16 GB is probably bare minimum. Don't go with 8 GBs. They just don't work. And then, but you should always confirm that you can add additional RAM without removing the old memory. Sometimes they sell you 16 GB and say, yes, you can upgrade to 32. And then they will have put 2 of 8, and then you have to remove the 2 of 8 and put 2 of 16. So that these are the things that you need to watch out for. Okay, they sell it to you and say it's upgradable without telling you what needs to be wasted in the future. And start with your, nowadays the SSDs are becoming affordable, your solid state disks. They really change your access to information on your disk, very fast boot up times. Then graphics cards, both NVIDIA and Radeon, AMD's Radeon are pretty, they're always trading their purple caps. Every couple of years, Radeon comes up and says, I'm the best and biggest in the market. And 2 years later, NVIDIA comes and says, I can do better. And so it's okay. You don't need to be caught up between those two. But when you go to try and buy a workstation, if you talk to the manufacturer like HP or Dell, you can sit and configure your machine. You don't have to buy what's on the website. Okay. Always make sure that you can output to multiple monitors. Because when you're mobile, when you're going around, you of course it's just your laptop. But when you're at your office or in a trying to work, then having multiple monitors makes a huge difference in the way you see things. For example, you could be using a program. You could be using Grasshopper and Rhino to create some complex geometry, and as you refresh it on another monitor, you can see the finished 3D model taking effect as you are programming. So that really makes a difference, and it doesn't clutter up your screen. You have huge monitors, 24, 28-inch monitors on the side, and of course you need a lot of desk space for that. So you need to plan your office accordingly. And always get your Pro OS if you're in a commercial practice, because that's the having home is only for students and non-commercial use. So you must invest in Pro version. I've noticed that many people buy a consumable laptop which comes with home, and then they are stuck with it. So you should not. You should try and avoid that and try to stay professional, both as an operating system and as a professional. Okay, and then always make sure your connectivity. Nowadays, Thunderbolts are very common. Make sure you have USB-Cs and Thunderbolts. See if you can include your LTE cards in it, so that you can be completely free of even a Wi-Fi network. If you have to, even in remote areas, at least you'll get 4G on it, and you can still continue communicating with your clients and your practice. So this sort of is a kind of a lab. But the price difference between, just in this one slide, the price difference between an i7 and a Xeon, or i7 and i9, or 16 GB and 64 GB, huge difference in prices. We'll take a look at that. Okay, so when discussing costs, there are workstation hardware, you have operating system, domain-specific software. When I say operating systems, I talked about Windows, Linux, or Mac, and then domain-specific software is all those little things I showed you in the BIM world. Apart from your Microsoft Office and things like that, licensing issues. Okay, nowadays what happens is licensing is a huge issue, because most of these software are sold as subscriptions. They are not sold to you; they are rented to you. So you pay a subscription, and the day you stop paying a subscription, that software just stops working, and that license stops working. So you need to watch out. It's a very important aspect of running your firm nowadays. Network storage. Robust and secure networking environment, you need to make sure. Otherwise, anytime you have a problem in the network, nobody can see the other. And in a BIM, you'd hardly ever work alone. You work in a collaborative environment. And when people lose communication with each other on the network, it leads to a lot of complications, sometimes even corruption of the model. Okay. And as well, doing routine upgrades to both your hardware and software. So this requires a lot of attention. It's not just the one bit of software that I'm talking about. So expect to spend between 2 to 3 lakhs per seat. This is completely out. This is only the hardware and software that I'm talking about. I'm not talking about your rest of the costs that go to setting up your office. Recently, we did an IT office for L&T, and their cost per seat, just the building cost itself came to, I think it came to about 3.5 to 4 lakh rupees per seat. By the time they put in all the number of people to work in a building, about 2,000 people, it came to an 80 crore building, and that's about 4 lakh per seat is just the building. And then add another 1.5 lakhs for the interior fit out, and then you add this IT requirement. So by the time I'm talking about an IT company, by the time they hire their first employee sitting to come in, that before they pay that employee's salary, they have already spent 10 lakh rupees per seat. So this is the kind of economics that you're going to see even in architects' offices, because of the huge role IT is beginning to play in our field. Then your subscriptions will run you quite a lot. There's, for example, Autodesk, for its Revit collection of software with Revit and AutoCAD and things like that, costs you about anywhere, depending on the deal you make, anywhere between 90,000 to 1.25 lakh per annum. Then you have other subscriptions such as your Microsoft Office and maybe your AMC on your computer run on the 10-15,000. It all depends on on the workstations. So you're looking, apart from your capital expense that you set up, you're looking at another 25,000 K per seat per month. That's like a virtual employee. Okay, so if you're, let's say you're paying your BIM expert, who's working, you're paying, I don't know what salaries, depending on experience, it could be anywhere from say 50,000 to 75,000, whatever. You have to keep adding that 25,000 in the back of your mind. That's the kind of money needs to be outlaid in your financial planning changes completely. From 10 years ago, what you thought you could run as an architect's office is now changed completely. Your IT budget comes into play. And in larger environments that's beyond, say, I don't know, 15, 20 seats, maybe even larger, you will need an IT person. Otherwise, anything goes wrong, the whole office will be waiting for that to be set right. So an IT person managing the network, whether you have it full time or you contract somebody to come in maybe twice a week, or Saturdays and Sundays they come in and check every system, keeping track of all your hardware, software, upgrades, licenses. And you will need a BIM manager, someone who is preferably an architect who is a subject matter expert. I'm not in favor of BIM managers being non-architects, because they may not see what's on site. I would like to have architects who go to site, understand what's happening on construction, understand not just the design process, but the modeling process and the end result at what the contractor wants, what the builder wants, what clients want. All that needs to be, that's why I'm using the acronym SME, which is subject matter expert, rather than just the ordinary BIM manager who handles the software in the office, who can work on training your existing staff and new hires, and retraining. Your existing staff need to be trained now and then. Every couple of years you may have to upgrade what they know. The software itself changes every couple of years. You may need to rethink how your software can be accessed, or rather how your software can be manipulated for better results, or interoperability with something new. So all these activities are part and parcel of an architect's practice nowadays. And we have seen it. We are also at all the time, we are trying to retrain ourselves. Like I told you, we have specific challenges with our sub-consultants, integrating their input into our models, trying to make a more comprehensive BIM. It's still because we are not as highly budgeted as a large contractor like some of the contractors that we have worked with. So set up your network. And nowadays, because of the unpredictability of lockdowns, set up your network and test it, such that if everyone's working from home or wherever they are, they can all tunnel in and see the server and each other as if they were in the office. That VPN capability and ability for everybody, once they log in from home, it's like they are in the office. That they are able to access files of the server, You don't need to email every heavy attachment. You can just work as if you're working on your LAN. And BIM, because a BIM production environment always require many of you all working together in collaboration. It's not a one-person environment anymore. Another thing in say, for example, Revit is any of your workstations. Let's say you have A, B, C as 3 workstations working on a project. Any one of them can become the group's project server, and that will hold, for example, the site and topography and all the external elements, and the 2 other people will be doing individual buildings, and the person guiding the project can simply, just like in AutoCAD, you have XREFs, similar to that in Revit, you pull in the buildings from your other group participants, and you create the full visualization. And so all this depends on good connectivity, and connectivity issues must be tested beforehand. You should keep doing, just like they do fire drills in tall buildings, you need to do a fire drill in your office as well. Now and then you need to make sure everybody can access information from home. Okay, here I want to end with a very, very amusing but very serious periodic table. This was done by somebody in I think in England. This is a periodic table. On the top, you can see the hyperlink. I'm not able to distribute. I tried to get permission from them to forward this to all of you, but next best is I have written. This is called the NBS. It's called the National Building Standards or something like that. That's NBS. It's a division of RIBA, Royal Institute of British Architects, and they have in their knowledge subfolder or in their website, they have a periodic table of BIM. There's an ebook. The ebook is very, very nice. It explains this entire periodic table, and let me just zoom in. I don't know. Let me see. You see here, they got color-coded squares, just like in your periodic table of elements, you got elements with different properties or valencies. Here, these are your valencies. You got strategy, foundations, collaboration, process, people, technology, standards, enabling tools, and resources. And these tables are arranged accordingly. For example, you see technology here. Technology talks about software, hardware, training, file storage, infrastructure. Everything that I talked about for the last few minutes is in this column. Okay, so this kind of classification of information and activity, it's like an activity chart, it's like a guide. Please download this. Please download this table from the website at thenbs.com. And there's a lot of other stuff about BIM there. You can a lot of self-study. I encourage people to do a lot of self-study. There are a lot of tutorials, you can whoever is the BIM manager or the trainer in your company can do a more detailed study and explain to others what this is. You don't have to implement all of this. You can implement some of it. You can start small. You can start with 2 workstations, 3 workstations, and then make it bigger. So it's something that I would encourage more and more to those who are going in for integrating BIM into their practice. Okay, so I will end the presentation, and I will go back to this slide and keep it open so you all can, whoever wants to keep seeing this, and we can now. I think I have to. I don't know if I have to close this. You can tell me regarding the question and answer session.
Hi, sir. We do have a question from Anand.
Yes.
Anand, could you please unmute yourself and ask the question directly to the speaker?
Anand Swami, yeah.
Anand Swami, yes. Hello, Anand Swami. Could you please unmute yourself?
Hello.
Yes, Anand Swami, we can hear you. Go ahead.
Yeah. Hi, Shrinath. Thank you so much for a fantastic presentation. Very comprehensive.
Thank you.
You didn't leave anything untouched. It's really a great job, great work, very hard work that you have done. Where I have a very simple question. Recently, I bought this Apple iMac
Okay.
with M1.
Yes. Yes.
And it's super fast. Actually, it is really. We bought one more MacBook also
Okay.
with M1, and it is really very fast, and the prices are so very affordable.
Yes.
Unlike earlier MacBook or iMacs.
Correct.
So can we use this? I mean, I feel that probably people will prefer this than Windows going ahead.
Yes, I agree with you. I am not. That's why I made it in the beginning that that is when I was talking about the software platforms or your operating platforms. It depends on the BIM environment that you're planning to go to. If it's for example Revit, I don't think Revit has a Mac version.
No, they don't have it.
Yes. So if you're in ArchiCAD, if you're using ArchiCAD, sure, why not? Mac's ArchiCAD, there is a version of ArchiCAD for Macintosh.
Yeah.
So if it's in the ArchiCAD world and Microsoft Office will run on Macs, right? There is a Microsoft Office or any other Office package that works with it. ArchiCAD and the other collaboration tools will work on a Mac environment. But it's not just one or two machines, Anant. It is your entire environment. Okay, it's a computing environment that I'm talking about. Because by the time, if it's just one or two machines and you're learning something, that's fine. But then you have to plan in the long term for a multiple users on your network, and or including what are your sub-consultants up to.
That's right.
Yeah, so this whole thing has to be studied. It's not easy. I know we have struggled a lot trying to especially with sub-consultants. We made a decision early on that we are not going with Macs. I know that Macs are definitely the quality of a Macintosh and the smoothness of certain things that it does. Even it starts even with your iPhone. But look at today. Even though iPhones are still the king of the hill, you still have a whole bunch of Android phones which are all competing, and still I think the majority of the phones around the world are Androids, and they may not be 100% the equal of an iPhone, but people have chosen that because for whatever reason, it's been marketed well. I will say that companies like Samsung or Redmi or whatever, they've all marketed their product well. And given products for much more economical solutions for a smartphone than an iPhone, even though we know that iPhone is probably what everybody wants to have.
Yeah.
Correct. So when you look at in your question about opinion on Mac, yes, I'm all for it, but I'm not looking at only the machine. I'm looking at your environment.
Yes, right.
Thank you so much, sir, for your valuable time.
Can I ask one more question?
Sure.
Yes, Anant, you'll have to be quick because we'll also have to be breaking for lunch. The next session will begin at 1:45.
Yeah.
Please be quick.
Yeah. So Shrinath, there's another thing which I used that is Morpholio on iPad. Hello.
Can you repeat what you said?
Morpholio.
Okay.
I use it on iPad. I mean, it's made for iPad, which is basically for sketching and doing some quick presentations.
Yes.
Is there anything that can then interface? Like the problem is that from there you cannot take it to AutoCAD or some other CAD software. It remains as a sketch or an initial presentation only. Is there anything that can help me out in that?
I'm not sure. I have to study.
Okay.
I don't have an answer immediately.
Okay.
I can share this one. But in Autodesk environment, they have Autodesk Sketchbook, and then I think there is a translation from that to AutoCAD.
All right. Thank you so much, sir, for your valuable time in explaining the importance and the use of integration softwares like BIM. I also have to thank you for sharing your real-life experiences and breaking down complex ideas to very simple ideas. And it's a quality that only a good mentor would possess. I also have to appreciate your efforts in tying up all the previous talks in this PDP. That's something that I noticed Thank you so much for that. Thank you so much for your time with us, sir. Have a great afternoon.
Sure.
Thank you.
Thank you. Thank you, everybody.